Hello, everyone. Uh, I hope I'm audible to you guys. We'll be starting in 5 minutes. We'll wait for a few more people to join. Okay, I guess it is a good time to start. First of all, please let me know, everybody, if I'm audible to you guys. Hello, am I audible to you guys?
Yes, sir.
Yes, sir.
Sorted, sorted, sorted. Okay, I'll start by sharing the screen. Yes, thank you, Rohit. I'll start by sharing my screen. And we'll be talking about, as I said, the topic we'll be talking about KTM 200 and Bullet 500, right? So, what is the purpose of today's session, right? Why do we have to talk about these two vehicles? Okay, so as engineers, do you ever have this question like a KTM is a 200cc bike and Bullet is a 500cc bike, but you can be pretty sure if you have a head-on race between these two vehicles, KTM would win, correct? Although it's of only 200cc. So that is the question that we will be trying to answer today. And with this, what I aim personally to give you guys is the knowledge of how these things work, why such thing happens, and also along with that, how we can you can recognize what kind of vehicle you're looking at just by seeing the specification sheet. So in the session at the end, I will simply open up the specification sheet for KTM 200 and Bullet 500, and we'll do a small comparison just on the basis of torque and power, how exactly you can recognize what type of bike it is. Okay. And with that, I guess we can start today's session. So I'm glad to announce that today we have associated with Sigma Groups of Institute, and they have been kind enough to host a webinar along with us. On behalf of ATG, I would like to welcome the institute on board with us, and we appreciate mentors like these institute who are willing to upskill their students and upskilling. I believe in giving a platform to students where they can learn more. So with that, I guess we can start today's session. So let me know if my screen is visible. I'll be starting this lecture. Okay, is my screen visible to you all?
Yes, sir.
Sorted. So before we start, I just want to let you guys know that this webinar is going to be more of a two-way communication. Okay, it's not going to be me telling you everything. It's going to be you telling me and me telling you. Okay, the conversation is going to be two-way, right? So at any point, if anybody feels that they don't understand anything, or if I'm speaking fast or whatever it is, you can simply unmute yourself, and we can have a conversation on it, right? So the main purpose of putting these two beasts in battle is to understand power and torque, right? So before we start, what do you think? What is your understanding for torque and power? If one of you or two of you might tell me. Okay, am I still audible to you guys?
Yes, sir, you're audible.
Yeah. So even when only times when I'm not audible to you guys is when I ask the question, if I'm not wrong. So what do you understand by torque? What do you understand by power? Anybody?
So torque is basically a radial force or a force applied at a distance.
Mm-hmm. Okay. And what is power according to you?
So according to definition, it can be the work done by unit time.
Okay. So
Sir,
see,
it breaks over.
yeah, SP, you said something. Hello. See, you don't have to be shy about anything. Even if you're wrong, I'm here to correct you guys. And if you're right, well and good. And only time that you'll learn in life is when you're wrong. So don't worry about being wrong. Just answer the question, even if you don't believe the question to be right. So with that note, SP, you were saying something. Yeah, Shri.
Power can be the task, uh, the time required to accomplish a task or something.
Okay. Good understanding. Anybody else? Give a shot to torque or to power.
Word force to do movement.
Hello.
Mm-hmm.
The torque is twisting force or power is uh, work per second. Work per second, sir.
Okay.
Per unit time.
Okay. Per unit time. Okay. Sriram Joshi is saying that torque is initial force like climbing a hill. Okay. Good examples. Climbing a hill in case of a vehicle, if I'm not wrong, sure. Correct? So let me give you my understanding of torque and power. Okay, and what I will do, I will break everything down to the core of basic units and basic things so that everybody is clear on this thing. So what is torque, right? So torque is nothing but the moment that is created. Okay, let me get my pen out. Okay, moment that is created about a point of rotation. Okay, that moment is torque. Now, how do we define torque? It's the product of force which has been applied, right? Multiplied by the distance between the center of rotation and the point of application of force. So this force, whatever it is, F, right, multiplied by this distance, if I call it D or X or whatever, right, let's call it D for example. So if I multiply this force, let's call it F, my torque will be force multiplied by this distance. Okay, by definition, it's the product of force and distance. Okay, so every time someone says there's a torque, there's always two things: there's a force and there's a distance. Now, how this distance comes into play? This distance is a radius to a circle. Always, it's a radius to a circle. Now, in this case of a spanner, this is the center and this is the point of application of force. And if you turn the spanner, it will rotate in a circular motion, which would look something like this, and it would end up back here again. Okay, I'm sorry for my artistic drawing, but I hope you get the point. Now, the center to that circle is where the torque is applied. Okay, where the torque is applied, or from where the torque is applied, depending on if you're driving or driven. Correct. So now that we're clear on two things. Number one, torque is a product of force and distance. It has two things, right? Second, torque is a moment about a center point, about a point of rotation. Okay. So to give you a good example, right? If you try to open a door, okay, if you're trying to open a door, have you noticed that all the doors have handles? The one where you pull, the one where you put your hand and pull. Those handles are always away from the hinges, right? So let's imagine if this is the wall, my hand is the wall, and there's a door like this, right? There's supposed to be hinges over here, right? So the handle would always be over here near my index finger or even my thumb, right? It will be always be near my index finger, and it will never be near my little finger. Okay. The reason behind that is if you push the door closer to the thumb, right, closer to the hinge, you would need to apply higher amount of force, because in that case, okay, your distance will be smaller, which is what we are seeing in the second image, right? So let's say if I take this spanner, the smallest spanner, right, force is same, right? We'll keep the force same. Now the only thing that has changed is this D. Okay, so instead of this D, now we have, let's say, D dash. Just for our understanding, we have D dash. So torque for smaller spanner, let's call it D dash, is now F into D dash. Okay, so if D is smaller, the torque will be smaller. Okay, if D, like over here, was higher, the torque was also higher. Okay, so this can be seen in our door example. So if, let's say, if this is the door, okay, and if I push the door at this point, it will be easier for me to push, right? It will easily open up with very less amount of force. But if I push it from here at this point, at very close to hinge at this point, right, it will be very difficult for me to push, because now the moment arm, right, the distance, the perpendicular distance between the center of rotation, which was this wall, and the point of application of force has reduced, right? So I need to apply more force to generate the same amount of torque. Every time you open a door, you are applying a torque. You're applying a force which gets converted into a torque, and that torque opens the door up. Amount of torque that you need to apply to open it up. So if the distance is larger, you need to apply lesser force for the same amount of torque. If the distance is smaller, you need to apply more amount of force for the same amount of torque. Is that clear to everybody?
Yes, sir.
Okay. Any doubt till now? If anybody has, I'm happy to answer. Till now, what we have discussed is what is torque, how it is applied. A practical example of it is a door. If you have a door around, you can simply go and check right now. If you want, you can open a door up and try to push it. Try to push it with placing your finger at the end of the door, okay, away from the hinge. And then at the same time, after that, what you can do is you can place your finger closer to the hinge and try to push it. You will notice that when you're closer to the hinge, you have to apply more amount of force, right? And that is because you need some amount of torque to open the door. And since the distance has decreased, now you need higher amount of force to achieve the same amount of torque, right? Now, how this applies practically? Okay, so let's say, since we are going to go for KTM 200 and Bullet 500, let's sort out an engine. Let's see how engine generates a torque, because we have always heard this term that this engine generates this much torque, this vehicle generates this much torque, right? So how does a torque work in an engine, right? So as you know, there are few parts in a vehicle. So we have in an engine, we have the piston, right? We have the piston, the connecting rod, which is over here, the connecting rod, and then we have the crankshaft, right? So the piston is connected to the crankshaft via a connecting rod, okay? And the crankshaft has a center over here at this point. Actually, let me change the color of the pen because diagram itself is red. Okay, the center is over here, somewhere over here, and the piston is connected over here at this point, right? And this piston moves up and down. It reciprocates up and down with the strokes. Okay, so just for your general knowledge, what are the 4 strokes in a 4-stroke engine? Could anybody tell me?
Sir, suction stroke, compression,
Correct.
expansion,
Correct.
and exhaust.
Correct. So suction, compression, expansion, which is also called as a power stroke, right? Expansion is a power stroke,
Yes,
and
sir.
then last is exhaust. Very good. So these four strokes, right? The piston is always moving up and down. So while in suction motion, while it's in suction stroke or intake stroke, the piston is moving downwards. While compressing or while in a compression stroke, it moves upwards, right? Again, in expansion or power stroke, it moves downwards. And then again in exhaust, it moves upwards. And the cycle repeats. The next stroke is going to be the suction stroke, in which the piston will be pushed downwards, right? So now when the piston is moving up and down, what we have done, we have connected the crankshaft and the connecting rod in such a way that this creates a rotary motion like this. Okay, this point rotates about the engine like this, so that at the same time we can get, while these strokes are happening, we can get a rotary motion out, and that is what we use to drive our vehicle. Okay, so now because we have converted the reciprocating motion of your piston to a rotary motion of your crankshaft, we have now gotten something which we need for torque, right? Like I said, torque is always around the center point, correct? Like we discussed over here, it is always around the center point. The center point was over here in this case. So now if I've got a rotational motion, it means I've gotten a center point, right? And there is a point of application of force, okay, which is this point, the connecting rod where it connects to the crankshaft. So this distance, okay, this distance where these 2 points are connected, let's call it X, is the distance, the perpendicular distance between point of application of force and the center of rotation. Okay, and that generates the torque. Okay, till now we haven't talked about this F, what this F is and how it comes and all those things. We are just focusing on this X. We are just focusing on the circular motion, and we've gotten the radius of that circular motion, and we are calling it X. Okay, so now for our torque equation, we need another thing, which is force. Till now we've gotten the distance, we need force also, right? And for force, over here, how do we develop the force? How do we generate the force, right? In all of these strokes, in all 4 strokes, where do you think the force is developed?
Power stroke.
Power stroke, correct? Expansion stroke or power stroke. In this stroke, the force is generated. What happens is we put air inside, we put fuel inside, and we burn it. And when we burn it, this piston is pushed downwards. Okay. When this is pushed downwards, the connecting rod is also pushed downwards over here. And this force, what we had, let's call it F, is directly transferred to your connecting rod at this point. Okay. And thereby we get the F of the equation, the second part of the equation that we need. Right. And that's how we generate torque in a vehicle, in an engine. Right. Okay. Till here, it's clear for everybody. We've talked about basics of torque. We talked about how torque is generated in an engine. Is that clear to everybody?
Yes, sir.
Yes.
Sorted. Is there any question from anybody? I'd like to answer it. Please let me know. Okay, sorted. Now, what is power? Okay, now that we are clear on torque, let's move on to power. Okay, somebody said power is work done upon time, right? By definition, it is work done upon time. So let's fundamentally understand what is work done upon time. Can somebody tell me what is work done?
It is the work done in time duration.
Yeah, so in that, what do you mean by work done?
The required movement.
The required
Movement.
Okay. So anytime you do work, right, you displace something. Okay, you displace something. So let's say if I have this pen over here and I want to move this pen from this point to this point. I hope the pen is visible. I'll have to go back to the camera mode over here. Yeah. So let's say if I have this pen over here and if I'm trying to move this pen here to here. Okay, everybody watch my screen, watch my camera if that's possible. Okay. So when it is at this point, it is at rest, right? I'm giving it some motion and I'm bringing it at another rest point, which is over here. Now, work done is defined by the product of the force that I've applied to move this pen this direction, okay, multiplied by the distance by which it has traveled. Okay, mathematically, that is work done. Okay, logically, what is work done? You pushed something by your hand and that thing moved. Okay, it's as simple as that. Okay, how far it went multiplied by how fast you pushed it or how hard you pushed it. That is work done. Right. So in case of this pen, it is moving from point A to point B. Let's consider this distance to be 1 meter, and I'm applying, let's say, 1 Newton of force. So the work done for this pen to move from this point to this point will be 1 Newton meter. Okay. And what is another unit for Newton meter? Can somebody tell me?
Pascal.
It's joule, right?
Yes, it's joule.
Joule. Pascal is actually Newton per meter square or Newton per mm square actually. Right? We all use Pascal in our strength of material subject, right? And in case of this pen, right, work done is joule. It is defined by joule, and that joule is Newton meter. 1 Newton multiplied by 1 meter gives you 1 amount of work done, 1 Newton meter of work done. Okay. So now, what exactly is power? Okay. Someone said power is nothing but work done upon time. So now we understand what is work done. It's the movement of this pen from point A to point B. And okay, sorry for interruption, Akash. Yes, you will get recorded video. We do post these videos on YouTube. So over there you can get the recording. Anyways, getting back to the point. Now the work done of this pen was 1 Newton meter because I moved this pen by 1 meter by applying 1 Newton of force. Now, what exactly do you mean by power? Because here in this equation, there is no mention of time. Okay. So now, what is power? So if this pen is moving from point A to point B, okay, and I'm applying 1 Newton of force, okay, and this displacement is happening in 1 second. Okay. Okay, this displacement is happening in 1 second. That means the power is equal to 1 meter, that is the distance, multiplied by 1 Newton, that is the force I applied, divided by 1 second, which is the time it took for the pen to move. Okay, that is mathematically. Okay, now talking logically. So if I'm taking this pen from point A to point B in 1 second, I'm giving some amount of power to it. Right now, if I take 10 seconds to move this pen from point A to point B slowly like this, right? It means I'm applying very little power to this pen. Although the work done is same, right? The force is same, the displacement is same, but since it's taking more time, it means I'm applying lesser power to this. Okay, and that is what power is. Work done upon time, which means how fast you do work is defined as power. Okay, is that clear to everybody, or should I give another example or another explanation for this?
Clear.
Clear? Sorted. Does anybody has any doubt till now? If you have any doubt, please let me know. Sorted. So I'll throw out one question for you guys. Okay, let's say I have this pen again, right? And I'm moving this pen not horizontally, but vertically like this, right? Like this. Now, if I'm taking 10 seconds to reach a point from one particular starting point, it gives me some amount of power. Let's call it X power. Okay, the first case is 10 seconds, and that is X amount of power. Now, let's say if I take the same pen and I displace it by the same distance within 5 seconds, okay, and let's call that Y power. So what do you guys say? Is X power greater or Y power greater?
Can you repeat the question, sir, please?
Sure. So I'm moving this pen from point A to point B, right? Now this is happening vertically, right? First of all, it happened horizontally. Now it's happening vertically. Now, because I'm moving my pen and it's taking me 10 seconds in the first case, and in second case it's taking me 5 seconds, right? So in which case I'm applying greater power, higher power? Is it in the first case or the second case?
Second case.
Second case, sir.
Okay, true. Okay, I got that everybody has the clear understanding of this concept. Yes, Hemant, Y power, correct. So with that, let's move on and see how exactly this power is related to our engine example. Okay, so now going back to our torque, right? We have our torque like we discussed in the previous slide over here, right? The torque was force multiplied by the distance. Now, how do you generate power? How do you calculate power, first of all, in an engine? Because we know, right? We know in engine power varies, right? In engine power varies, right? So now, what is the time element in this arrangement? Okay, can somebody tell me what is the time element in this in this arrangement? Because to calculate power, we need time, correct? Calculate the power, we need time. But in this case, we don't have any time. Okay, where is the time element in this arrangement? Where can you find a time element?
Time taken in each stage of piston movement.
Correct, correct. And somebody has mentioned speed. Okay, time taken for each piston movement. Very good. That could be a solution for that, right? Now, how do we represent it? How do we represent time taken for the piston to move, or the speed of the engine for that matter? Now, first of all, let me be clear, the speed of engine versus the speed of your vehicle are going to be different. They don't run at the same speed, right? Engine can be working at different speed and your vehicle will be running at a different speed. So how do we define the speed of engine? Anybody? Okay, have you guys heard of the term RPM?
Yes, sir. You always refer me.
Revolution per minute, right? What does it mean? If I say my engine idles at 1,500 RPM, what does it mean?
It's a revolution of piston in per minute.
Okay, revolution of piston per minute.
Means crankshaft
Anybody
is
else?
rotating.
Okay, the crankshaft is rotating. Okay, very good answers. What it means is, if I have, let's say, this rotation happening, right? This is the rotation we have in the engine, correct? Like we saw on the previous slide, this is the rotation we have. Now, this rotation, how many time it happens per minute is the count we call RPM. Okay. If I say 1,500 RPM is the idling condition of my engine, it means when I turn on the engine, if I don't accelerate, my engine's crankshaft rotates 1,500 times per minute. Okay, 1,500 times per minute. And that is what RPM means. Now that's the time element we got, right? Now, how do we calculate the RPM? How do we calculate the power in case of engine? Power is equal to torque multiplied by RPM. Okay. Now, how do we replace work done by time? Okay, because power is also equal to work done by time, correct? Is that correct? This equation is true for everybody?
Yes, sir.
Okay. So what is RPM? It is rotation per minute, correct? That's the keyword. It means here there is something happening per minute, which means this goes into the denominator. So right away, when I say RPM, instead of RPM, I can write this down per minute. Okay. And since we are talking about torque, okay, and the engine is going to, the crankshaft is going to follow a circumferential path while rotating, correct? Because it is forming a circle and it is going to follow a circumferential path. We can calculate the number of rotations, correct? We can calculate the number of rotations, and that will give me the distance, correct? That will give me the distance. So that's why we have R per minute. or RPM. That's what we call it, right? R per minute. Now, when we multiply this by the torque, we get the power. What this means for an engine, okay? What this means for an engine, if the engine RPM, okay, the torque is going to be one and the same, because the torque is going to be constant based on, or the torque is going to be changed according to the force that is applied, correct? This force can vary, correct? Now, if I keep this force constant, let's say if I keep this force constant, in this case, the power may change. How the power will change? I can change the RPM, correct? I can change the RPM. If I keep the force constant, and if I want to change the torque, I can simply change the X. Is that clear to everybody?
Yes.
Hello?
Yes. Yes, sir.
Sorted. So now, with this, we get our equations for power and we get our equation for torque. Now going to the application part of it, okay? Where do we need torque? Where do we need torque and where do we need power? So have you guys ever driven a bike which has gear, or have you guys driven a car which has manual transmission? Anybody has driven a car or ridden a bike with gear? You guys can unmute yourself. It's not a difficult question. Yes, Siddesh, you can unmute yourself directly. You don't have to, raise your hand.
Yes, sir.
Yes, sir.
Okay. So while driving a car or a bike, if you're going up a slope, okay, if you're going up a slope, do you put your vehicle in a lower gear or a higher gear? Do you go in a first gear or fifth, sixth gear?
First gear.
Lower gear.
Lower gear, sir.
Lower gear, correct?
Yes,
Yeah,
sir.
first gear. Okay. Now just remember this fact, and I'll give you an example of why we go in the first gear. Okay. So I'll go to this presentation again. Okay. We have this classic example in physics. Okay, where we have this slope going like this, right? There's a slope, and let's say there's a box over here. Okay, and on this box there are 4 forces acting. Okay, always, no matter what you're doing, there are 4 forces acting on it. Initially, we have the frictional force, okay, which is resisting all the, if the box is at rest, okay, let's consider this to be at rest, okay, the frictional force is resisting all the forces that are acting on the box, okay. So here, first of all, there will be a component of your gravitational force, or the force which is acting because of the mass of the box, right? There will be a component of this mass of the box which will be pulling it downwards the slope, correct? And if it is at rest, there will be another force. There will be another force which will be opposing in direction and equal in magnitude. Okay, if this force is F, this will also be F. Okay, and this force, this yellow force, is coming from here, from the friction between the box and the slope. Now let's say if I increase the F over here, if I increase this F, red F, okay, and frictional force cannot increase, okay, beyond a point, what will happen? The box will move downwards. Is that correct?
Yes.
Okay. Now, let's say if I do another example, if I take another example, and now let's reverse the cases. Okay. So let's say if I'm applying a force this way, there's a frictional force in the opposite direction, which I'll again draw with yellow. Right. And now I'm applying some force which has to be greater than this frictional force. Okay. We'll call this F and we'll call this F dash. So as long as F dash is equal to F, there will be no movement, correct? Is that clear to everybody?
Yes, sir.
Sorted. And as soon as F dash is greater than F, the box will move upwards. Correct?
Yes, sir.
Sorted. So same thing happens with your car or your bike. If I draw a very, very dirty model of a car, okay, it has its wheels like this, right? The entire load of the car is acting at 2 wheels over here and over here. And there is some friction. Again, I'll use yellow ink for the friction between the tire and the road. Correct? Now, let me draw some road. Okay, there's some friction between tire and the road, and there's some load acting by the mass of the vehicle to the at that frictional point. Now, if I want to push this vehicle forward, if I wanted to move forward, let me draw a motion by yellow. If I wanted to go, blue. If I wanted to go forward, I need to apply some force. Okay, I need to apply some force over here, correct, at the tire in this direction. Am I right? Is that clear to everybody?
Yes, sir.
Sorted. Okay. Now, how can I apply this force? Okay. So first of all, how do we walk? We walk by getting a reaction force from the ground, which means if I rotate my wheels, let me maybe select a black color. Okay. If I rotate the wheel in this direction, in clockwise direction, right? Okay. The wheel, if I zoom in this part, okay, the wheel and the ground, right? The wheel will push the ground backward, correct? Because it is rotating this way. It will push the ground backwards. Am I correct? Am I right?
Yes, sir.
And because of that, the ground will push the wheel in this direction. Correct? That's the reaction force. Third law of Newton. Every action has an equal and opposite reaction. Correct? So now I need to get this force, this red force, which is over here. Correct? For that, what I will do, I will rotate the wheel in this way so that I get a my tire applies some force over here, right, to the ground, and the ground pushes the vehicle forward, and that's how the vehicle goes forward. Okay. Now, what do we need at this point? We need this force, correct? This red force. Am I right? We need the red force. Okay. On which entity is the red force dependent upon? What do you think?
Surface.
Air
on which the car is.
Okay, surface is constant.
Inertia of the vehicle, air resistance, drag,
Okay.
friction of the wheel.
There's one key thing which we can control. I'll give you a hint. These are the things that we cannot control: air resistance, friction of the surface, the resistance of the weight of the vehicle, and all those things we cannot control, right? Something when you're sitting inside a car, you control. Acceleration. When you increase the acceleration, this is the force you're increasing, the black force, right? This is the force you increase. When you increase this force, this red force also increases. Correct? This is the action force. When you increase the action force, it is always equal to the reaction force. Your reaction force is always equal to the action force. If you increase the action force, the reaction force will also increase. The red is our reaction force, the black is our action force, right? So if you want to increase this force, okay, this is the force, there is a rotation happening, there's a center, okay, what do we get over here? Can somebody tell me?
Pardon, wait.
We got a radius, we got a rotation, we have a force. What do we get?
Torque, you get a torque.
Correct. That's what we saw in the first slide, correct? When we have a force and a distance, we get a torque during a rotation, right? So we have this force, we have this radius of the tire, we'll get torque. F multiply R will be torque. Now, there is again some amount of torque we need to apply, or some amount of force we need to apply to move forward, correct? That will be the action force. Now, if on the go, while you're on the vehicle, you cannot change this R, so this becomes constant, right? If you want to increase this force, okay, you'll have to increase the torque, correct? And when you're sitting inside a car, the first, second, third gear, or mostly the first gear, will give you the maximum torque, okay? That is why when you're starting a vehicle or when you're going up a slope, you always keep your vehicle at lower gear, because you need to get more torque so that you can get more action force. Is that clear to everybody?
Yes.
Okay, sorted? Okay, any doubt till now? If anybody has, please let me know. I'll be happy to answer it.
Sir, if action and reaction forces are equal, how will the car move forward?
Okay, let's forget all this. Let's say you're sitting inside a boat. Okay. Now, when you're in a boat and you have that, what do you call it, a row, right? I don't know what it's called, but when you row a boat, right, when you have that in your hand and you're pushing the water backwards, correct? Technically, you're pushing the water backwards, correct? Now that water is applying force on that row, and that row is applying force on your body. Your body is applying force on the boat, and the boat is moving forward. Am I correct? Okay, so technically, your action force is pushing the water backwards. The water is trying to resist. It doesn't want to move. It doesn't want to move backwards. That is why it is pushing you forward. Correct? The same thing happens over here. Instead of water, you have ground, you have land. Okay. And to be very honest, land is much more stubborn when compared to water. It does not want to move. It will push you forward. So even when the action and reaction forces are same, it doesn't mean that the wheel is getting the force in this direction. It means the wheel is applying the force in this direction, right? On the left direction. And the ground is pushing you forward. Because it is stubborn, it does not want to move, it will push you forward with that force. And that is how you get the reaction force. Okay, is that clear?
Yes, sir.
Sorted. Is there any other doubt, anybody? Or should I move to how power works in a vehicle?
What about this gearless transmission? This torque will vary based on the, again, acceleration only. How exactly that will be converted? Is there any mechanism which internally it happens? I think so. You may not shift the gear, but internally it happens into the lower gear ratio where torque will be more.
Okay, for some reason I was on mute. So there's something called as CVT, continuously variable transmission. The CVT is designed in a way that it automatically changes the ratio, your gear ratio, and you get a variable torque, right? And that requires its own separate bootcamp to understand. So I'll not get into that, but there is an equipment which gives you variable torque, right? And in other cases where there is no CVT, okay, there are vehicles in which you don't put any CVT.
Sir, you're on mute.
Your system is getting muted frequently.
No, sir, somebody in the meeting may be muting you.
Okay.
How we can mute others?
Push Patel is muting everybody. Push Patel, can you turn on your camera? If you can't, please leave the call.
Okay, you continue.
No, this is the third or fourth time we are facing this kind of issue. So Kush Patel, please kindly turn on your camera, or you can leave, or I would request anybody from Elite Techno Groups to remove Kush Patel.
Who is that Push Patel? Gentleman.
Yes, sir.
Yeah, you talked to Kush Patel. Please try to understand the problem. Have you understood Arbaz's request, no? Don't try to operate anything. Please only hear to him. Okay, Arbaz, please continue.
Sure. Thank you, Jaina. Okay, Siddesh, you have your hand raised. Do you want to say something?
पहले किया था वो उसका
I know. I've been through this. Okay, please let me know if my mic goes on mute again. We'll take strict action to it. And Kush, if you want to study, then only, if you want to learn, then only please be on the call, or you are welcome to leave the call. Okay, so moving on to the power. Okay, so now we were talking about the torque and how torque affects the vehicle, right? Now let's say the vehicle is in motion. Okay, what do you need out of a vehicle then, right? You need, when you want to go in higher speed, you need higher rotation of your engine, right? And that's where the power comes in. Now, like we said, what is power? It's the torque multiplied by the RPM, right? Torque multiplied by the RPM. Now, if I have RPM, right? If I have RPM, I need, for power, I need to either increase the torque or the RPM, correct? To get it to a higher speed, right? To get it to a higher power. So what I can do is I can either increase the torque or increase the RPM to increase the power, correct? And when you accelerate, what happens is more and more fuel is drawn in this chamber, and it pushes the piston more vigorously, and that's why you get higher force, right? And since it's pushing it at a much higher velocity, much higher force, it goes into a much higher RPM, and that's how you get higher RPM. So when you accelerate, you are basically increasing the power by increasing the torque and the RPM. Okay, to a certain point, torque and RPM increase. Torque and power increase continuously. Okay, at some point, torque stops increasing and power stops keep on increasing for some point, and then after that, the power will stop increasing. Okay, so before we get into how the power and torque works, okay, let's first go to how the torque is varied in an engine. Okay, now there is something called a short stroke and long stroke engine. Okay, so what is a stroke and a bore? So if I talk about this engine, right, the displacement that is happening of the piston vertically, it is called the stroke. Okay, and the diameter inside the cylinder is called bore. Okay, so there are bore and stroke of any engine. So there are short stroke engine and long stroke engine. Okay, so if the bore is greater than the stroke, we call it to be short stroke. Okay, that is a short stroke engine. On the other hand, if it is opposite, okay, the bore is lesser than the stroke, in this case, we call it to be a long stroke. Okay, and because of what we have done is we have described the bore to stroke ratio, and we have somehow managed to keep it in a square. So if I trace the top part, which is over here, and the bottom part of the piston, which is over here, and if I draw a four-sided figure, it comes out to be a square. So this is called a squared engine, where bore to stroke ratio is 1. Okay, which means bore is equal to stroke in that case. Okay, if bore to stroke ratio is 1, it means that bore is equal to stroke, and that is called a squared engine. Okay, and if bore is greater than stroke, it is called a short stroke engine or over square engine. Okay, over square engine. And if the bore is lesser than stroke, right, it is called a long stroke engine and underscore a square engine. Okay, now from our understanding of our torque over here, what do you think will happen to torque in these cases? Okay, let's not talk about square for a while. Let's talk about short stroke. Okay, short stroke and long stroke. Where do you think the torque will be higher, in short stroke or in long stroke?
Long stroke.
Right. So the torque will be higher in long stroke. Okay, somebody said short. Could you tell me what is the reason of going with short stroke for higher torque?
Sir, because the distance from the crankshaft to the crank is higher, and the torque will be more there.
Okay, but this distance is lower, na? This distance, right? This is the x distance, the radius of the circle that has been traced, right? The radius of the circle is lesser.
Sir, I said in long stroke, torque.
Okay, long stroke torque is more. Somebody said short stroke torque is more.
No, sir, I didn't say.
Okay. So is that clear to everybody? Long stroke torque will be more, short stroke torque will be less. And can everybody mute yourself for now? SP, you're on unmute. Could you mute yourself? And Amia.
Sir, I am muted.
Okay. Abhinay and Amia, please mute yourself. Okay, thank you. Okay, so we understand that for long stroke the torque will be more, for short stroke the torque will be less. Now I will tell you for the same amount of fuel expense, right? The same amount of fuel expense, or for the same amount of distance travel, right? In which case the power will be more, in short stroke or long stroke? Let me reframe the question. Right?
Short.
Hello.
It will be short stroke.
Okay. So why that happens? Could somebody give me an explanation quickly?
Because it travels only smaller portion, the pressure acting on the piston will be more in short stroke.
Okay.
Speed is also more, sir.
Speed is more. That's the main reason. So if you think about, if you see these three examples, right? During the time this piston reaches the downstroke, right? It is traveling more distance, right? If I give each of them the same speed, this will travel more times, more number of times, correct? Right now, the speed of these three are different. That's why they are traveling at together from TDC to BTC, correct? At the same time, they reach the top dead center, and at the same time, they reach the bottom dead center, because the speed of these three are different. If I give them the same speed, if the piston speed is same for all three, this rotation will happen very quickly, right? And it will happen at least 2 or 3 times before this one rotation happens, or one stroke happens, correct? So because of that, the RPM will increase, which means the speed of the engine will increase, which means the power will be higher in the short stroke engine. And comparatively, the power will be lower in the long stroke engine. Is that clear to everybody?
Yes, sir.
All racing cars will have this effect.
Correct. So that's what we'll be talking about when we compare in the next slide. When we compare. Correct. Okay. Right. So as you can see, we'll just first of all discuss about the torque and the power of these two vehicles. Okay. So max power for our KTM 200, right, is 25 PS at 10,000 RPM. Whereas for the Bullet, it's 27 PS for 5,250 RPM. Right now, you'll be saying, sir, whatever you're saying that more power will be in KTM and less power will be in Bullet, but here the Bullet has more power. But if you think about it, here we have the RPM as well, right? Here we have the RPM as well, because the maximum power of a Bullet will be achieved at 5,000 RPM, but the maximum power of the KTM will be extended up to 10,000 RPM. Okay. On the other hand, if we talk about the torque, right, the torque of your KTM is maximum of 19.5 Newton meter, whereas in a Bullet, it's 41.3 Newton meter, which is almost more than double, right? It's more than double basically. Right. Now we'll get to the chart and how this works and how RPM is related to torque and power. But before that, let's figure out what kind of engines these two have, right? So we have the stroke and the bore of our KTM. So on the right, we have KTM, and on the left, we have the Enfield, right? So we have the stroke and bore of both engines, right? So you tell me, what kind of engine does KTM have? Is it a short stroke or long stroke?
Long stroke.
Okay. Somebody said long stroke. Could you give me a reason for that?
Or high torque.
Hello. Okay, it is going to be short stroke because the bore is greater than the stroke. Okay. If I take a ratio of these two, right, the stroke is going to be more. Sorry, the bore is going to be more, the stroke is going to be less. That's why it is a short stroke engine. Okay, short stroke engine. On the other hand, in case of your Bullet, although it is more or less the same, there's 6 mm of difference, but it is still a long stroke engine. Okay, it is still a long stroke engine. Now, what we had discussed, in a long stroke engine, torque will be higher. In a short stroke engine, torque will be lower. Okay, is that clear to everybody? Till now, we are not talked about power. We'll be talking about power in a bit. Is that clear to everybody?
Yes, sir. Yes.
Sorted. Now going to this curve. Okay, so this is a curve which is more or less followed by all the vehicles. The only thing is the value of the power, torque, and the RPM changes, but the profile of the curve is more or less same for all the vehicles. Okay, so as you can see, there's going to be the torque curve and the power curve. Okay, as we increase the RPM, till some point, both of them will rise. Okay, there'll be a peak point for power, there'll be a peak point for torque, and then they'll start to drop. Okay, both of them will behave the same way. Now let's see according to our, let's talk about power now. Okay, so for power, we'll take the blue curve, right? The red curve, right? And in this case, we have 25 PS of power, right? Which will be somewhere around here, right? 25 PS. Let's use this as a scale of PS, not kilowatt, just for our understanding. And 25 will be somewhere around here, right? So here will be the peak power. And if I calculate, if I write this to be 7,000, then there'll be one for 8,000, 9,000, and then there'll be one for 10,000, correct? So here I'll have somewhere around here, there'll be 10,000. And if I draw a line for 25, it will look something like this, right? And over here, the power will be max, right? Starting from here, the power will be max over here for a KTM vehicle, right? KTM 200. But if I talk about a bullet, right, it's going to be 43 Newton meter at 4,000 RPM. Okay, so if I go over here, if I go to 4,000 RPM and go to 43 Newton meters, somewhere around here, right? That's where the power is going to be max, and it is going to be deplete fast, somewhere around here. So for a bullet, right? If you check out the tachometer on a bullet, right? Tachometer is a device on which you measure the RPM. If you check out the tachometer of a bullet, you'll notice the RPM, maximum RPM will not be more than 7,000 or 8,000. Okay. Whereas in KTM, the maximum RPM that it can go will be up to 13,000. Okay. Why? Because in this case, the maximum power is going up to 10,000 RPM. Whereas in this case, the maximum power is only up to 4,000 RPM. Okay. And that is why you cannot extend it up to 10,000, because after this, the power is just going to go down, right? And you cannot use that power to drive your vehicle. Now, because of this, what happens is once your vehicle is in motion, right, it will be somewhere around 3,000 or 4,000 RPM, right, when it's in motion. And when you increase the accelerator, the RPM will increase and the power will keep on increasing. Okay, the power will keep on increasing. And as long as the power is increasing, you will get increase in speed. Okay, is that clear to everybody? You will get increase in speed. So that is why when you drive a Duke 200, right, your speed increases even when you're beyond, 4,000, 5,000, 6,000 RPM. It keeps on increasing. But in case of your bullet, when you go beyond 4,000 RPM, your speed will not increase. You have to change the gear. Okay, is that clear? Okay, is that clear to everybody?
Yes, sir.
Sorted. So that is why power and torque, like that is why the short stroke and long stroke have different power curves, and that is why they have to be used in different applications. Right? Now, one more thing before we wrap up.
Excuse me, sir. So you're muted again. Say muted.
You are muted.
Hello.
Arbaz,
I said I request everybody to turn on their video. Anybody who doesn't have their video on will be removed from the meeting.
Sir, I don't have camera in my laptop.
Okay.
Sir, I'm using on laptop.
No problem. You can join from phone and turn on the video. Okay, let's continue. I don't think I'll be muted again. Okay, so the last thing that I wanted to talk about is the applications of these two things. Okay, the applications of these two vehicles. So when we have a vehicle,
Again,
So you are muted again.
I know. Hold on. Okay, sorry about that, guys. We are looking into it. We've been facing this problem for past 2-3 webinars, and okay. So I was saying the last thing that we can take from this kind of
there may be some Arbaz, some system
Okay, everybody. Again, sorry about that. So like I was saying, the last thing that I want to talk about is selection of a vehicle for a particular application. Okay. So how could you select a vehicle for a particular application, right? So let's say if you need a bullet, if you need a vehicle that will go off-road conditions, go on, climb mountains, climb hills, in that case, you would need higher torque, right? You wouldn't need higher power. So in that case, you can go with a vehicle which delivers you higher torque at a lower RPM. Okay, like a bullet, right? It'll deliver you higher torque at a lower RPM. On the other hand, if you need some kind of vehicle which you want to go faster, right? If you want to go your vehicle to be a fast one, in that case, you would select a vehicle which will deliver maximum power to you at a higher RPM, like a KTM 200. Okay, is that clear to everybody?
Yes, sir. Sir, if you need both, then
okay. So there's always going to be some trade-off between these two. Okay, you'll have to manage these things. But what engineers have done is the vehicle which is of higher torque will not only be for higher torque, it will also have higher speed. So you can take a bullet and go at higher speeds as well, but it'll take you much more of your fuel. On the other hand, if you want to go at a higher torque, you can use your KTM, but it will be very, very slow. Okay, it will be very, very slow and it will again take a higher amount of fuel. Okay, so that's how the engines are made. That's how the vehicles are made, so that they deliver both the things to you on the cost of your fuel. Okay, but majorly, if you want efficient working at a higher speed, you go with a vehicle which delivers higher power at higher RPM. And if you want a vehicle which climbs up slopes and overcomes obstacles and go off-road, in that case, you would need higher torque at lower RPM.
okay, sir. And sir, can you please elaborate about the RPM, sir? What revolutions are we talking about? Of the crankshaft or of the wheel or of the
no, of the crankshaft. So when you see a tachometer on your vehicle, it's always about the crankshaft. Okay, and that is the revolution per minute that we talk about. So how many times your crankshaft rotates per minute?
Okay, sir.
Okay, so in the chat box, I am putting up the feedback form link. Please do fill the feedback form. It gives us insights on how to improve our bootcamps. And also, along with this bootcamp, after completion of this bootcamp, we are providing free courses to everybody who attend our bootcamp, just so you can kickstart your upskilling, kickstart your learning, and become industry ready. And it is as simple as filling this form up, and you'll get the access for the free course. And along with this, one more thing that I wanted to mention, while filling up this form, make sure that you have registered on the website first, because the certificate is generated automatically. So anybody who has registered on the website and fill up the form will get the certificate. So if you have only filled up the form, you won't get the certificate. If you only register on the website, you won't be getting the certificate. So you need both these things: the registration on website and you have to fill the form which I have provided in the chat box. Is that clear to everybody?
Clear, sir, clear.
Sorted. So please do fill up the feedback form. Like I said, it gives us insights on how to improve. And also it will give you a free course so that you can, start upscaling yourself and learn more with what you have started in this bootcamp. Chandragupta is asking, what is the registration process? So it's simple. You just go to elitetechnogroups.com. Okay. And from there, on the top, you'll see webinar written next to internship and courses. There'll be a box for webinar. When you click on it, you'll see the list of webinars that are there, and from there you can register. Okay. I hope that is clear to everybody. With that, I'd like to end today's bootcamp. It was really great having you guys. And thanks once again to Sigma Group of Institute for hosting this webinar with Elite Techno Groups. And I hope you guys have taken what you came expecting for this video or for this bootcamp. And I hope to see you in the next one. Till then, keep learning and keep exploring. Thank you.
Thank you, sir. Thank you.
Thank you, Arshad. That means a lot.
Thank you, sir.
And those who have filled up the form you may leave the call. It's not a problem. And if you have any doubt still, I'll wait for like 2-3 minutes more. If you have any doubt, please let me know.
Thank you, sir.
Sure. Sorted. If there are no more doubts, I guess we all can leave. Thank you everybody for attending once again, and keep learning and keep exploring.
Please continue such webinars, Arbaz, because
Sure.
those things will definitely give some, I see participants numbers are literally increasing. It is a good sign. It is a good sign, but we have to take a little, it may take a little longer time for people to get inspired, but you are all doing a wonderful job. I am very, very happy with a simple presentation, making people to understand.
Thank you. That means a lot.
Arbaz and ETG team.
Thank you. Thank you very much.
Thank you. Bye-bye.
हेलो सर।
Yes, Shiva sir, tell me.
सर वो आपने बोर का कंसेप्ट बताया ना, वो फिर एक बार बता सकते हैं क्या? मैं अभी डिस्कनेक्ट हो गया था उस टाइम पे।
अच्छा, तो देखो पिस्टन जो सिलेंडर बनता है ना, उसमें दो चीजें होती है, एक बोर होता है, एक स्ट्रोक होता है। बोर इज द इंटरनल डायमीटर ऑफ द सिलेंडर जिसके अंदर पिस्टन फिट होता है, एंड स्ट्रोक इज द डिस्टेंस द पिस्टन्स ट्रैवल वर्टिकली। ओके, तो ये होता है बोर एंड स्ट्रोक।
सर और ये 4 व्हीलर में 2 लीटर इंजन वगैरह रहते हैं ना, वो 2 लीटर क्या होता है?
Okay, the 2 liter is actually the displacement of the engine. When I say displacement, जो piston move होता है ना, how much volume it is displaced by. Okay, वो ऊपर नीचे जब जाता है तो कितना volume वो displace करता है, that is the measurement of your displacement, and that is what cc means, that is what liter means, right? 200 cc मतलब वो 200 cubic centimeter का displacement करता है engine. When I say 200 liter, combining all the cylinders that are there, उनका कितना वॉल्यूमेट्रिक डिस्प्लेसमेंट है, दैट इज 2 लीटर।
ओके सर, थैंक यू।
सर मुझे एक सवाल है।
यस श्रीराम।
सर 4 व्हीलर में 4 सिलेंडर इंजन रहता है, उसके वक्त एक बड़ा सिलेंडर रहता तो
ठीक है। सो यू आर सेइंग कि कोई भी इंजन जब 4 सिलेंडर है, कुड इट बी सिंगल सिलेंडर, है ना?
यस सर।
ओके, सो बहुत सारे रीजंस होते हैं यार टू मेक अ मल्टीपल सिलेंडर इंजन, बिकॉज फर्स्ट ऑफ ऑल व्हेन यू गो फॉर द सिंगल सिलेंडर एंड ट्राई टू डेवलप अ हायर अमाउंट ऑफ पावर, योर हीट जनरेशन इंक्रीजेस। ओके, एंड ठीक है, there's a square cube law, there's actually square cube law we call, which dictates how much volume is there in a body versus how much surface area is there in a body, right? To clear this up a little bit more, let's say surface area is something that is responsible for cooling of an engine, right? Because the higher surface area it has, it will cool faster. अगर मैं एक ही सिलेंडर लूँ और एक ही पिस्टन लूँ, ठीक है, उसका वॉल्यूम बहुत बढ़ जाएगा, बट सरफेस एरिया उतना ही रहेगा, वो जो सर्कल है। सो सरफेस एरिया वर्सेस वॉल्यूम में सरफेस एरिया हार जाता है, दैट्स व्हाई वी कैन नॉट कूल दैट इंजन फास्टर, और उसमें हीटिंग वाले इश्यूज आ जाते हैं। So general rule of thumb, people say 500 cc is the maximum an engine could be. Okay, 500 cc could be a maximum of engine that could be there. with without any external help. If you want to go more than 500, it'll need something external. ठीक है, तो इसके लिए we don't go with that. And बहुत सारे advantages होते हैं when you go with a higher power वाला engine. उसके अंदर you need a bigger flywheel, you need balancing issues आते हैं इसके अंदर. So when you have 4 cylinder, you can balance them out equally, and you can, instead of a flywheel, one cylinder helps the other to move on.
Okay, sir. Thank you, sir.
Yeah, not a problem. Okay, most of you are asking what is the registration process. Please go to our website and register for the webinar that you'll be seeing. Sure, I'll send the feedback form link once again. So here, and I'll also send the website link over here. Okay, sorted. There are no more doubts. I think we can conclude the call. Once again, thank you everybody for joining. It was really great interacting with you guys. Thanks a lot, and see you in the next one. Bye-bye.
Thank you, sir.